This video covers the new Task and Event Decompiler in EnvisionProject. This tool will support maintenance on existing sites where the commissioning engineer does not possess the source code EVT files for the project. It allows the ability to decompile the code from existing tasks and events held within the devices. One particular scenario where this is a key requirement is decompiling events from a Dynalite time clock. Events can be added or edited directly on this device, so it is important to prevent certain situations where it is possible to overwrite events that customers have edited. We have arrived to a site and the project file is unavailable. After completing a thorough visual check to confirm which Philips Dynalite products are on site, we then connect to the network, start a new project, and then search for devices. By clicking Add and Load Devices, tasks and events are automatically decompiled as the device is loaded into EnvisionProject. Returning to the network view, we can see that a number of devices have tasks stored. This is represented by the green tick to the left of the device. If we highlight a panel and select the Task and Event Editor, we can view the details that the decompiler has extracted. At the top of the window, it will display the time of the most recent decompile. As mentioned, tasks and events are automatically decompiled when a device is initially loaded into EnvisionProject. It is then the choice of the programmer as to whether the information is kept or a new EVT file is created. At first glance, the code that has been decompiled seems organized and should allow the programmer to understand what the task or event was trying to achieve. However, there are some key points that need to be understood in relation to what the decompiler captures. What isn't captured? Comments. Any comments contained in the original file are not captured. On our screen, the white window shows the decompiled code, while the left window displays the original task in the project file. Notice that the comments are no longer present in the decompiled code. Hash constants. It is common for some programmers to add hash constants. These are entered at the top of the EVT file. The decompiler doesn't capture all of the hash constant information, but the logic is processed. In this example, the hash constants are used to replace area numbers with names in the code. The hash constants in the left-hand window are not displayed in the decompiled code on the right. If we compare task 2, notice the decompiled code on the right replaces the names with the original area numbers. Unused tasks. Devices have the capacity to store a number of tasks. If those tasks were unused, then the task syntax is not captured by the decompiler. Notice in our comparison, the original EVT file has 8 tasks, but only 2 were used, so the other 6 are not displayed in the decompiled file. The other tasks can still be used, but the correct task syntax will need to be written to allow the EVT file to be recompiled. Notice on the screen, if task 3 is required, the relevant syntax is retyped. What is displayed differently? Label names. If the code contains any labels, the original label names will not be displayed. They are replaced with a syntax beginning at L001 that continues in sequence depending on how many labels you have. All label references are returned and updated to the new syntax. Comparing the code on screen, notice the new label sequence in the decompiled code, which directly replaces the original label names. Start commands. Any start commands in the original code will be displayed with the relevant Dynet string in brackets that it is listening for. A programmer will need to be able to decipher the Dynet message to understand what is triggering the command. In our example, the original start command is listening for a dummy area message using area 210. Notice how this has been converted to a Dynet string in the decompiled version on the right. Named actions. One of the clever features of the decompiler is that it will convert certain Dynet strings into their equivalent task command syntax. Notice in this example how some of the strings are displayed with the relevant task commands in the decompiled code on the right. As you can see, the Dynet string is still shown but has been commented out at the end of the line. Time clock. The DTC602 time clock device allows the customer to create, edit and delete events without the assistance of a programmer. For this reason, the decompiler will be an important tool to be able to retrieve any customer changes. Scenario 1. If arriving on site with the project file, it is recommended to reload the device data from the time clock. Then open the EVT file. In our example, the first two events are disabled. The customer has enabled them again via the time clock panel. To see those changes, from the task editor, click Decompile Events Only. This will capture any task changes or additions. Notice the two events have now been updated and are now enabled. Scenario 2. If arriving on site without a project file, once the time clock is discovered from the network search, clicking Add and Load Devices will decompile all task and event data. That concludes the video on the task and event decompiler.